Yes, sir. ಶುರು ಮಾಡ್ಲಾ sir?
1 minute. So, good evening, Munandar. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಇಂದಿನ ವಿಜ್ಞಾನ ಪ್ರತಿಭಾಶೋಧ ಯೋಜನೆಯ 88ನೇ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಶ್ರೀಮತಿ ಚೈತ್ರಾ ರವರನ್ನು ಸ್ವಾಗತಿಸುತ್ತಿದ್ದೇನೆ. ಐ ವೆಲ್ಕಮ್ ಟು ಯು ಮ್ಯಾಮ್.
Thank you, sir.
ಹಾಗೂ ಇಂದಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹಾಜರಾಗಿರುವ ನನ್ನೆಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಅಧ್ಯಾಪಕರು, ಶಿಕ್ಷಕರು ಹಾಗೂ ನನ್ನ ಸಹೋದ್ಯೋಗಿ ಮಿತ್ರರನ್ನು ಕೂಡ ಈ ಒಂದು ಉಪನ್ಯಾಸಕ್ಕೆ ಸ್ವಾಗತಿಸುತ್ತಿದ್ದೇನೆ. ಸೊ ಹಾಗೂ ಸಮಯಾವಕಾಶ ಕಡಿಮೆ ಇರುವ ಕಾರಣ ನಾನು ನೇರವಾಗಿ ಈ ಒಂದು ವಿದ್ಯಾರ್ಥಿ ಪ್ರತಿಭಾಶೋಧ ಯೋಜನೆಯ 88ನೇ ಉಪನ್ಯಾಸ ಮಾಲೆಗೆ ಶ್ರೀಮತಿ ಚೈತ್ರ ಅವರನ್ನು ಮತ್ತೊಮ್ಮೆ ಸ್ವಾಗತಿಸುತ್ತಾ, ಓವರ್ ಟು ಯು ಮ್ಯಾಮ್.
Yes, sir. Thank you so much. Hello, students. Good evening, everyone. This is Amines Part 3. I hope last 2 classes we have completed preparation methods, as well as in the second part of amines, I have completed basic nature of amines, right? So in the last class, we have started with chemical properties of amines, correct? Chemical properties of amines. Under that, we clearly understood that in gaseous phase, in aqueous phase, what is the basic nature of amines, correct? So in today's class, we will be continuing with the chemical properties of amines apart from the basic nature. Okay, in detail we have already understood that. So let me take the first reaction with respect to chemical properties of amines. The one thing you have to keep remembering is the main reactions of amines are due to the presence of lone pair of electrons, correct? If you take ammonia or amines, what is present on nitrogen? There are lone pair of electrons. So these is the reason for the majority of the reactions of amines. Okay, so basically they act as nucleophilic agents, since they can donate this lone pair of electrons for the species who seek electrons, correct? No, so who seek electrons? Electrophiles. So they are acting as nucleophilic reagents. Okay, keeping that in mind, we will be taking the second chemical reaction. The salt formation, you can directly tell, then I'll go for the reactions. So as I told, amines being basic in nature, they combines with mineral acids. Okay, mineral acids means you can take either HCl or H2SO4. Okay, let me take one of the example as HCl and show you the reactions. Okay, yes. Now I'll write one amine. You can write primary, secondary as well as tertiary. Take this amine. On nitrogen, there is lone pair of electrons. So this is nothing but alkyl amine. One general amine I have taken. Okay. Plus, for this, I will add HCl. So when you add HCl to amine, amine being basic forms RNH2 HCl. So add up. Correct? No? Or else you can represent this only like, see, this is H plus, this is Cl minus, this is nucleophilic reagent. So it takes H plus forming RNH3. Nitrogen gave that pair of electrons to H plus. So now you get positive charge on nitrogen and you have this compound, correct? So I can call this as N alkyl Because that alkyl group is attached to what, students? Alkyl group is attached to what? This nitrogen. So I can call this as N-alkyl ammonium, N-alkyl ammonium chloride. Okay, this also explains the basic nature of amines. In the presence of mineral acid, RNH2 is behaving like base. Okay, and one more thing, in the last class I have even told you, for example, this is the amine species which has been produced here, ammonium species produced here. In case you want to regenerate the amine back, what you have to do? Can you recollect? I have RNH3 plus Cl minus. Now for this, if I add a strong base, in such case, I can regenerate the amine back. So I'll get RNH2, okay, and Na plus and Cl minus. You get one of the byproduct as NaCl plus what is left out from here, H plus and OH minus. You can write water. Okay, this is an important point. You can regenerate the amine by treating this with NaOH, that is strong base. Okay, this is one of the property. Similarly, you can take secondary amines as well as tertiary amines also. They also show the reaction because this reaction is basically based on the presence of lone pair of electrons. Okay, let's move ahead with the next set of reaction, chemical properties. So next, third reaction, reaction with alkyl halides. How these amines react with alkyl halides. Remember we learned a reaction called as Hoffman's ammonolysis in the preparation method. It is exactly the same. Now let me take one general reaction where I am writing RNH2. This is considered as primary amine. Okay. Now on the arrow mark, I'll take R dash X. Can you identify what is this, students? What is this? R dash X. R dash why I have written means to differentiate this R from the amine. Okay. You can simply write Rx also. Basically, this method we studied to prepare, remember, primary, secondary, tertiary and quaternary amines. Now, I am just showing once again how these amines are going to react with the alkyl halides. Now, you know here Rx bond is polar, X minus is formed because halogen is more electronegative. Now, in this case, what happens? Yes, can you tell me? This is a substitution reaction. Remove this HX and attach this R dash. So I get R NH R dash. So this is called as secondary amine. Why? Because nitrogen is attached to how many carbon atoms, students, here? Nitrogen is directly attached to how many carbon atoms? 2 carbon atoms. Correct? No. Now, next, again on the arrow mark, one more mole of Rx. I'll take R dash X. Now, what will happen? Again, substitute this hydrogen, remove this X, you get HX as the byproduct, and I'm going to get R, N, R dash, and R dash. So, I got a tertiary amine. Similarly, if you treat with one more mole of alkyl halide, I'll be getting a quaternary amine. Okay, so I'll be getting R, N, lone pair is gone now because this R dash will utilize that. I'll get R dash, and R dash. Okay, this is called as quaternary amine because nitrogen is directly attached to how many carbon atoms in this case? 4 carbon atoms. Okay, this is nothing but Hoffman's ammonolysis only. This is how when you take a alkyl halide, it will react with the amines in this manner to give secondary, tertiary and quaternary amines. Okay, So this is one example for alkyl amines. Already I had written this in the preparation method. Now what I'll do, I'll take an example of aromatic amine. Okay. Give me an example for aromatic amine. Yes, students. Now I'll show the same reaction by taking alkyl halide and aromatic amine. Do you remember any aromatic amine? This is the most important one. Yes. Do you remember we had written aniline? Benzene ring directly attached to NH2 is aniline. This is also called as benzenamine. Correct? No? Now one more thing here you have to remember is what is the order of reactivity of this R-X we are taking. Correct? So, for example, if I have RI bond, RBR bond, RCl bond, and RF bond, can you identify among this which will react faster? Where the reactivity order is more among alkyl, iodide, bromide, chloride, and fluoride? Yes, you can think. Yes. Now we know that, let me consider R is nothing but carbon only. I have carbon and iodine bond, carbon and bromine bond, carbon and chlorine bond, carbon and fluorine bond. What happens down the group for halogens? The size of the halogen increases. So size increases means what happens to bond length? Keeping carbon fixed, bond length also increases. So bond length increases means bond dissociation enthalpy decreases. Therefore, what is the order of reactivity of alkyl halides, whatever you are taking? Correct? This is the reactivity order. Why Ri is more reactive? Because of the bond length reason. Now, one more thing, you should be taking alkyl halides only as the source of this alkyl group. Because if you take aryl halide, what happens? Aryl halide, when I take, what happens? Halogen will be directly attached to the carbon, which is sp2 hybridized. So partial double bond character comes, bond length becomes shorter, bond dissociation enthalpy becomes higher. That's why I can't take that. Okay. Now let me continue. I have taken a primary aromatic amine. This is called as aniline. Now I will add for this methyl iodide. Why did I take methyl iodide? Means it is more reactive. That's why. Okay. Heated. What will happen? Substitution. So you substitute this alkyl group here and remove 1 mole of HI. So remove here HI and attach. What is left out here? NH is left out. 1H I have removed with I and I will attach here CH3. Now this is nothing but secondary amine. Secondary amine. Nitrogen is directly attached to 2 carbon atoms. This is called as N-methyl. N-methyl. Yes, N-methyl what? This entire structure I'll consider it as aniline. Okay. Now reaction will again continue if I take excess of alkyl halide. Okay. Now again on the arrow mark I will write what? CH3I. Can you write the next reaction? Continue it. Now replaceable hydrogen is there right here. So what will happen? Remove that, attach CH3 here. On nitrogen again lone pair is there. So 1 more mole of HI you removed. Can you tell me what kind of amine it is? Nitrogen is directly attached to 3 carbon atoms. So I can call it as tertiary amine. Okay. At last, one lone pair is there, no, one nitrogen. So 1 more mole of methyl iodide I will take. So how the bond cleavage happens here? I minus CH3 plus. Correct? No. Now this electrophile attacks this nucleophilic reagent and utilizes this lone pair of electrons and forms a bond. So you will get NCH3 thrice in the vicinity of the positive species only, negative ion will be there. So finally, this nitrogen is attached to here 3 carbon atoms plus here 1 more carbon atom. So can I call this as quaternary amine, guys? Yes. So this is quaternary amine. I can call this as trimethyl anilinium iodide. Okay. This is one of the reaction with alkyl halides. How do amines, that is, I have taken the example of primary alkyl amine as well as primary aryl amine or aromatic amine to show you the reaction. This is actually called as exhaustive methylation. I'm keep on introducing what group to this? Aniline. I'm introducing methyl group. That's why it is called as exhaustive methylation. Okay. Or else simply you can call this method in general as what? What, guys? You're introducing every time what groups? Can you tell me? You are introducing alkyl groups. That's why it is called as alkylation. Okay. Yes. Now, next reaction. We'll move ahead. Fourth reaction I'm taking. So, now we will understand how these amines react with acid chlorides. You know the general formula of acid chlorides? How it reacts with acid chlorides and acid anhydrides. How it reacts with acid chlorides and acid anhydrides. Okay. So if you introduce or in the reaction acid chloride react, what happens? What is the electrophile generated? And here also acid anhydride, you will generate a group which will have CH3CO. This is called as acyl group. Okay, whether you take acid chloride or acid anhydride, you will have this group. This group is called as acyl group, or it is also called as acetyl group. Therefore, this particular reaction has one more name, that is called as acylation or acetylation. The last case, I told you how to introduce alkyl group. In this case, I'll show you how to do this acylation or acetylation. Okay. Again, I'll take 3 cases in this case. One is with uh, firstly, I'll take aliphatic amines. Under that, I'll take primary, secondary, and tertiary. Okay. And the second case, I'll take aromatic amines also. Let's try to understand what is the product we will be seeing. Okay. In fact, this reaction acts as differentiating test between primary, secondary, and tertiary amines. When I take aliphatic amines. Why? Because you will be getting different varieties of product in the first 2 cases, and in the last case, whatever I told tertiary amine, what will happen? You are going to experience in this. Fine. So let me take the aliphatic amines. Okay. Under this only, I will take 2 sections. One is, let me take aliphatic amines. Aliphatic amines. What are aliphatic amines? Open chain structures. Okay. So with aliphatic amine, firstly, I am taking primary amine. Okay, primary amine, write the general structure, or we can also write the direct examples only. Since we don't have lot of time, I'll directly teach you the example instead of one general reaction. Okay, let me take one primary amine. C2H5NH2 or nitrogen lone pair is there. What is this called as? Yes, ethylamine, right? Now, I will first take this example, okay, acid chloride. Then second case, I'll take acid anhydride. Now, I'll write acid chloride in this manner. I'll write which acid chloride I'll take means I'll take acetyl chloride. The common name for this group is called as acetyl group, no? So, it is called as acetyl chloride. It's called as acetyl chloride. Numbering from where we have to do, if you have to write the IUPAC name, can you tell me from where we have to do the numbering? This one, this carbonyl chloride group. 1, 2. Actually, if you check the functional group priority order and check the suffix, for this one, we would have given the name as oil halide. So since here chlorine is there, I'll be calling it as oil chloride. Can you tell me how many carbon atoms are there? 2 carbon atoms. So the root word becomes what? Ethan oil. Ethanol chloride. Now do the reaction. In fact, on the aromatic you can take pyridine also. Pyridine is a base. What is the purpose? I will tell you later. Now do the reaction. Yes. Actually, if you want to show the intermediate, I'll show like this. You once see what happens. This is a nucleophile. Now this works as what? C double bond O. It is a electro withdrawing group. This oxygen is more electronegative. It pulls the electrons towards itself. Carbon base a positive charge. Okay. Now I'll get actually here, if I consider this as RNH2 plus, I'm considering one general example to tell you the intermediate. Like this I have one general acid chloride and amine, primary amine only I considered. This is nucleophilic in nature. This is electron withdrawing group. So this nucleophilic agent goes and attaches to this carbon because it is electrophilic. Correct? No. What do I get? Therefore, R dash C single bond O minus, and then I have Cl attached to that. Then this R NH2 through nitrogen it is attaching and R group is there. Correct? This is NH2. On nitrogen, what charge I should write now? Positive charge. Correct? Are you following, guys? Positive charge I should write. Okay. Now you see here. Now this Cl group act as a living group and this H, whatever I am writing, that H goes out as H plus because the Cl minus subtract that. Okay. Now that pair of electrons, whatever H plus is leaving behind, it will neutralize this positive charge. Therefore, I will be having R, this I'm writing, N, H, then C. This negative charge will come back here to satisfy the valency, double bond O and R dash I'll be having. This is the product I'll get. Similarly, in this case also, for a simplicity, what you can do, from here you remove Cl and H you remove, it will go out as HCl and you have C2H5. And what is left out here? NH and you write a bond. And here C double bond O and CH3. This is the final compound you got along with the byproduct what guys? HCl. Correct? So I can call this as N. What is this group? Alkyl group. N ethyl. This group is called as acetamide. Acetamide. N ethyl acetamide. The final product. Okay. This is the story of aliphatic primary amine. Now, let me take one secondary amine and tell what I will get. Okay. So, I got what product is here? N alkyl substituted amine. N substituted amine. Okay. N ethyl acetamide I got. Now, secondly, I will take a secondary amine. Now, which amine I will take? C2H5. Not only I will take C2H5 twice NH. Now, this is a secondary amine. Plus, once again, I'll add acetyl chloride only. Tell me what will go out. HCl will go out and I get C2H5 twice. Okay. N C double bond O CH3. Now what's the name of this? Can you tell me? It is N comma N. See, 2 times alkyl group is attached to this nitrogen. So for every group you have to tell it is attached to nitrogen, no? To depict that, you have to tell N comma N diethyl, N comma N diethyl. What is this part? Acetamide. NH C double bond O or N C double bond O is there means, bond is there means, you will call it as acetamide. See, earlier you got N alkyl amide. Now you are getting N comma N disubstituted amide. Understood? Now lastly, I'll take a tertiary amine. Now once again, C2H5 thrice. Nitrogen is attached to that. This is tertiary amine, and I'll take same reagent, that is acetyl chloride. Can you think and tell me what would be the product? Yes, try. Here there is no reaction. Why there is no reaction? Because there is no replaceable hydrogen only. Correct? No. So since no hydrogen is attached to nitrogen which is replaceable, the reaction doesn't happen. Okay. So this is what I told in the beginning. This works as a distinguishing test for primary, secondary and tertiary amines, where tertiary amines don't show the reaction. Secondary amine shows N, N disubstituted product. Primary amine shows one substituted, N substituted amide. Okay. So this works as a distinguishing test for amines. Okay. And one more thing, why did I write on the arrow mark base? Why did I write on the arrow mark base? Means, now I told this is the major product, means one of the byproduct is HCl. Now can you tell me HCl is base, HCl is acid and the base whatever I am taking is pyridine here. In this case pyridine I will take. It's a base. So acid plus base. What happens? Neutralization, correct? No? So whatever the acid is formed, this base keeps removing that acid and thereby shifting the reaction in the forward direction to increase the E. Okay, that is the significance. Okay. So this is a test between primary, secondary and tertiary amines. Now, first part I spoke about the alkyl amines or aliphatic amines, how they will react. Now, second case, let me take aromatic amines with aromatic amines. How the reaction happens. Okay. Yes. Let me take this. I am taking aniline. Again, I am taking primary amine only. This is primary aromatic amine and I am adding same acetyl chloride. Okay. On the arrow mark, I'll write pyridine or you can just write a base and heat it. What will happen? One of the hydrogen and Cl, you replace, HCl will go out and I will be getting benzene ring directly attached to what is remaining here? NH, correct? And here Cl went. So C double bond OCH3. This is called as N. Outside important functional group is there. Therefore, this acts as the substituent. Therefore, I'll call this as N phenyl. What is this group? Acetamide. It has one more very important common name. It is called as acetanilide. Acetanilide. Okay. Or else, see once again, let me take this aniline only. Instead of using acetyl chloride as the acyl derivative, I'll take acetic anhydride. All of you know what is acetic anhydride? Can you tell me the formula? I have already given the hint. Look at this, CH3CO twice O. So I'll open and write for your convenience. CH3 C double bond O, because otherwise carbon valency won't satisfy. O C double bond O CH3. So this is acetic anhydride. How acetic anhydride is prepared? When you treat acetic acid in the presence of dehydrating agent, it removes 1 mole of water and you get acetic anhydride. Correct? Now you tell me, can you cleave carbon-carbon bond here? No. Carbon-oxygen is polar. So who is more electronegative? Oxygen is more electronegative. That takes a proton and goes out as acetic acid. Whereas this part, a cation is there, no? That will go and attach to NH. So I'll be getting CO, CH3. See, the product is same only. Whether you take acetyl chloride as the acyl derivative or acetic anhydride as the acyl derivative, so you will be getting N-phenylacetamide or acetanilide as the product. Special reaction is there. Let me code that here only. Now I'll take once again aromatic amine. With aromatic amine, these reactions are very special actually. Now, instead of acyl group, I'm going to consider this. Tell me the name for this. If C6H5 is directly attached to CH2, it is called as benzyl group. If C6H5 is directly attached to C double bond O, it is called as benzoyl group. Okay? This is called as benzoyl chloride. Now do the same reaction, but you have to conduct the reaction in the presence of a base. Okay. Now what will happen? Once again, same process. Remove HCl and you will be writing benzene ring NH. So that's CO, CH3, sorry, C6H5. Earlier CH3 was there, now C6H5. Can you tell me what is the name of this compound? Yes. What is the name? N. What is attached for N? Phenyl. This group is called as benzamide. Benzamide. And this is called as benzanilide. So many uses these compounds, whatever we are preparing, they have. Benzanilide. Okay? Benzanilide. Okay, so this is called as not acylation or acetylation. Instead, you introduce what group? Benzoylation. This is, you introduce benzoyl group. Therefore, this particular reaction is called as benzoylation. So I took an example of aromatic amine. You can also take aliphatic amine. So benzoylation of aliphatic, or aromatic amines with benzoyl chloride in the presence of aqueous NaOH. That particular reaction is called as, it has got a name, it is called as cotton Bauman reaction. Just have a note of this. So acetylation is different. This is different. Okay, this is not acetylation. This is benzoylation. So benzoylation of aliphatic or aromatic amines in the presence of benzoyl chloride and NaOH is nothing but what? Cotton-Bauman reaction. Okay, this is one major reaction we studied today. Next, was the second reaction I took here. Reaction with acid chloride and acid anhydride. Continue the number. Next, I'll take fifth reaction. So this is the most important reaction. Again, this works as a distinguishing test. I'll take carbyl amine reaction. Carbyl amine reaction. Okay. So this reaction is answered by, or shown by only primary amines. Only primary amines. You can take aliphatic primary amines as well as aromatic primary amines. Answer this, but only primary amines. So this test is acting as a distinguishing test. Secondary and tertiary amines do not answer this test. Only primary amines answer this. So this test is used to separate or distinguish primary amines from secondary and tertiary amines. Okay, let's learn what is this reaction. It's a very important reaction in your board as well as like NEET, CET and other entrance examination. Many a times they have asked this question, carbyl amine test. So what is this test? Let us understand first. Okay, so write the reaction. I'm taking one general reaction first. RNH2. This represents a amine. I told you already what kind of amines answer this. Primary amines. You can take whether aliphatic or aromatic, anything, primary amine you take and heat that amine with CHCl3. Can you tell me what is this? What is CHCl3? Chloroform. So you heat this amine, primary aromatic or aliphatic amine with chloroform in the presence of alcoholic solution of potash, that is potassium hydroxide. Heat it. Alcoholic solution of potassium hydroxide. When you heat this, you will be getting in this case, if I consider R as alkyl, I'll get alkyl isocyanide. If carbon is directly attached to N, then C is there, NC, isocyanide. If carbon is directly attached to RCN like this, it is cyanide. If RNC is there, it is called as what? Isocyanide. I got isocyanide. This is only called as carbylamine. Carbylamine. It has a very bad odor or foul smell. It has foul or obnoxious smelling. Obnoxious smell. Intolerable smell. Okay. So you take amine, primary amine, heat it with chloroform and alcoholic potash. You get isocyanide or carbylamine. That proves that if you get isocyanides, it is answering the test for primary amines. Okay. So you can write the examples for this. One of the example, let me take alkyl C2H5NH2 plus CHCl3 plus actually 3 moles of KOH is required to balance the reaction. Okay, heat it. You will be getting ethyl. If you are taking ethylamine, you will get ethyl isocyanide. If you are taking methylamine, you will get methyl isocyanide like that. So you get C2H5 and C. This is called as ethyl isocyanide. Ethyl isocyanide. Or it can also be called as common name ethyl carbyl amine. Ethyl carbyl amine. Plus obviously your byproducts will be there. KCl will be the byproduct as well as water will be the byproduct. So this is the major product which you should not forget. Okay. So let me take one more example for you. I'll take now aromatic primary amine. Can you tell me now what is the product? Reagents are same only. I'll add chloroform and alcoholic KOH. Heat it. I should get isocyanide, right? So attach benzene ring to NC. I got phenyl isocyanide or phenyl carbylamine plus byproduct. Fine. Will secondary amines give this test? Will secondary amines answer this test? No, right? Only who answered? Primary answer. Secondary and tertiary amines don't answer this test. So if you check the mechanism, this reaction is involving a electrophile called as dichlorocarbene. Have a note of this. Who is the electrophile for carbylamine test or carbylamine reaction means it is called as dichlorocarbene. This is one of the reaction intermediate. Around carbon, how many electrons are there? 1, 2, 3, 4, 5, 6. So it is short of electron. Okay. If you have studied special reactions of phenol, you would have studied Reimer-Tiemann reaction, right? To prepare salicylaldehyde. What is the electrophile for that reaction? It's the same thing, dichlorocarbene, correct? Okay. This is one more set of reaction which is very important distinguishing test. So primary amines, aliphatic and aromatic amines, answer this. Secondary and tertiary don't answer. Okay. Let's go ahead with the next reaction. Next one, reaction with nitrous acid. Reaction with nitrous acid. Nitric acid means what? HNO3. What is nitrous acid? HNO2. So once again, primary, secondary and tertiary amines react, they react differently with nitrous acid. Okay. So one more thing you have to note down here is this nitrous acid, whatever I wrote, it is unstable. It's unstable. So therefore, you have to do the in situ preparation by adding sodium nitrite and HCl dilute. So you don't take HNO2 directly. It is not available since it is unstable. You have to do in the reaction mixture itself. In situ preparation of HNO2 you have to do by taking NaNO2 and dilute HCl. Okay, when you add NaNO2 and HCl, what will form? HNO2 and HNO2 and NaCl will be the byproduct. So during this, electrophile will be generated which continues the reaction. So this nitrous acid, whatever I took, nitrous acid, it is a source of electrophile nitrosonium ion. Nitrosonium ion, which is nothing but nitrogen carries positive charge, double bond oxygen. This is what reacts with amine. So let us go ahead in learning the reaction. Understood? The next reaction, what we have taken? Reaction with nitrous acid. All the amines will not behave in the same way. They behave differently. So again, you can use it as a distinguishing test. So here HNO2 is unstable. So I am doing the in situ preparation. And this nitrous acid is acting as the electrophile source. Who is the electrophile? Nitrosonium ion. Okay. So let me take once again primary aromatic amine as well as primary aliphatic amine as well as aromatic amine. Okay. Primary I will show. Secondary. Okay. Let me show the reaction. So firstly, I am taking primary aliphatic amine. Primary aliphatic amine. Okay. Now, first one example only I'll give. I'm taking C2H5NH2. On the arrow mark, either you can write HNO2 or you can write NaNO2 plus HCl in situ preparation. Okay. Now, this will form a unstable diazonium salt. Ethyl diazonium chloride, you will call it as. This is unstable. So nitrogen gas has to release. Next, if you warm with water, what will happen? No, water ionizes as H plus and OH minus. This N2 plus nitrogen carries positive charge. It takes this pair of electrons and liberates as N2 gas plus H plus and Cl minus. Again, HCl is a byproduct plus C2H5 is there, no? that attaches with the OH minus and you get ethanol. If you take primary aliphatic amine, you get alcohol as the product with the release of nitrogen and HCl. Let me take now aromatic amine, aniline, and do the same reaction, nitrous acid. Instead of this alkyl diazonium halide, I'll get BDC. That is nothing but benzene diazonium chloride. Benzene diazonium chloride, it should be read as nitrogen is carrying positive charge. It pulls the electrons towards itself and goes out as nitrogen gas. Correct? Plus HCl will be liberated when you warm with water. This is about 278 Kelvin approximately, warm with water, and OH minus will go and attach to the benzene ring. So thereby, if I take primary aliphatic amine, I'll get alcohol as a product. If I take primary aromatic amine, I get phenol as the product. Okay. Whereas secondary and tertiary amines behave differently. Okay. So one reaction I'll show you for secondary if you want. Let me take secondary amine. This is secondary amine R2NH, 2R group I have attached. When you treat this with HNO2, nitrous acid, I'll open and write like this. Both aliphatic as well as aromatic amines, they react with secondary amines. Sorry, both aliphatic and aromatic secondary amines react with nitrous acid to give N-nitrosoamines, which are water insoluble, and they separate out as yellow oily liquid layer. See, this is a simple condensation reaction. Remove water, so thereby you will be getting R2N. Okay, so here for nitrogen you attach this one more bond and double bond. Who is the nitrogen valency has to be satisfied? No. So this is called as N nitroso. That's electrophile actually. Nitroso. Dialkyl amine. This is called as N-nitroso dialkyl amine. This is a water insoluble species, insoluble, and it will separate out as a yellow oily layer. Remember? So this is how, compared to primary amines, secondary amines react differently. Okay. Okay, next one more reaction I'll take. Seventh one. Reaction with aryl, then C6H5 group only. Aryl sulfonyl chloride. This is one of the important reagent. How these amines react with aryl sulfonyl chloride. Okay, this is also a test to differentiate primary, secondary, and tertiary amines. They all react differently. And one more thing, this is a very excellent method to separate primary, secondary, and tertiary amines. Excellent method to separate primary, secondary, and tertiary amines. Okay. So firstly, this aryl sulfonyl chloride structure I'll write and show you. Aryl group, sulfonyl chloride, or you can also simply write it as benzene ring attached to SO2 and Cl. This is called also benzene sulfonyl chloride. Benzene sulfonyl chloride. It is also called as Kingsberg Hinsberg reagent. Hinsberg reagent. Okay, so let's understand how reaction will happen. So let me take first general reactions. I'll write and show you primary amines. Okay, now I'm writing benzene sulfonyl chloride, Hinsberg reagent. So firstly, what you have to do, you have to treat this sulfonyl chloride with the amine. Then you get a product like this. You remove HCl, R, NH, SO2, benzene ring. This is called as N-alkyl benzene, benzene, sulfonamide, sulfonamide. This is a white solid. Okay, this is a white solid. Okay, now next I'll make this reaction alkaline. Whatever the mixture I got, I'll add a alkali for that. Now, what I'll get is here, one of the replaceable hydrogen is there. When you treat it with this complex, whatever you have got in this compound with NaOH, I'll be getting R. This proton will be abstracted, N minus and Na plus sits here, and I have SO2 and benzene ring. Basically, this is a soluble salt. When you add excess alkali, what happens? Whatever the white solid was there, it dissolves completely. If you want, in case, to reconfirm back, what you can do, take for this soluble salt, add once again HCl. What should form? With the removal of that NaCl, once again H plus goes here, so that white solid reappears. White solid, whatever earlier you got, it reappears. Okay guys, this is a confirmatory test. So when I take primary amine and treat it with Hinsberg reagent, what happened? I got N-alkyl benzene sulfonamide, which was a white solid. And when I made this mixture alkaline by adding aqueous NaOH, what happened? This, whatever the white solid was formed, that compound was soluble in excess of NaOH. To confirm back whether it is primary or not, if you add HCl, that white solid reappears back. That is the observation bit. Okay. So next, let me take secondary amine. Secondary amine. I'm taking R2NH and treat it with benzene sulfonyl chloride. Now what will happen again? Replaceable hydrogen is there. Remove HCl, write R2NSO2 benzene ring. Again, this is a white PPT. White PPT. This is called as N, N dialkyl benzene, benzene sulfonamide. Sulfonamide. Okay. This is white PPT. Now what I'm doing, same like earlier case, I'm adding NaOH guys. I added NaOH. So what should happen? In the earlier case, what happened? That whatever the salt formed, that was soluble. But here what happens? No reaction. So no reaction. There is no replaceable hydrogen. See here. No reaction. Right? So even if you add excess NaOH, that particular white PPD, whatever is formed, it is insoluble in excess of sodium hydroxide. So primary amine, when you take, what happens? Whatever the compound formed, white compound form, precipitate form, it is soluble in excess alkali, whereas when you take secondary amines, that white PPT form will not be soluble even though you add excess NaOH. Are you getting my point? So lastly, let me take tertiary. Tertiary. Okay, I'll write R3N. Tertiary amine. Now once again, I'm taking benzene, sulfonyl, chloride. Okay. So now you have to look at the reaction and tell me whether the reaction happens or not. Clearly observe here. What was the criteria? Here replaceable hydrogen was there, HCl went out and you got a salt. Right? A compound you got. Then upon adding NaOH you were getting a salt. Now if you take here secondary amine also you had a hydrogen here. You removed HCl and you got this white PPT. Now to do that, do you have any hydrogen in this case? No. So tertiary amine will not contain any replaceable hydrogen. So what happens? No reaction. Okay. So this is also one of the important distinguishing methods to separate primary, secondary, and tertiary amines. Okay. So in this today's class, the third part of amines, what and all we learned, let's quickly go through. We learned the chemical properties or chemical reactions of amines. The last class we understood the basic nature of amines. So here also we are continuing with the different reagents, that's it, to understand. Yeah, obviously amines are basic in nature. Firstly, I told about the salt formation. With mineral acids, amines react to form N-alkyl ammonium chlorides, whereas again if you want to regenerate that amine back, you can add a strong alkali to get back the original amine. Then next reaction with alkyl halide, that is also called as alkylation, Hoffman's ammonolysis. So here we understood how amines react with alkyl halides to form a mixture of amines. And you also understood this. It's a preparation method of amines, and this is not a good method because it yields mixture. Separation will be difficult. And also reactivity order of alkyl halides, Ri is greater, Rf is least. When I took aromatic amines, that particular reaction was called as exhaustive methylation. Next, we understood reaction with acid chloride or acid anhydrides. Here, basically, you will be introducing acyl group to the amines. That's why it's called as acylation. This is also working as distinguishing test between primary, secondary, and tertiary. When you took primary amine, I got N-alkyl amides, whereas secondary N and dialkyl amides. Tertiary will not show the reaction because of the absence of hydrogen. Whereas when I took aromatic amines, you got an important compound like acetanilide. Instead of if I take instead of acetyl chloride, benzoyl chloride, I got benzanilide, which is called as cotton-Bowman reaction. Then carbylamine test also works as distinguishing test between primary and secondary and tertiary amines. Only primary aliphatic and aromatic amines answer this test because the formation of foul-smelling carbylamines, which are also isocyanides. And next reaction with nitrous acid works as the distinguishing test between primary, secondary, and tertiary. Primary gives like primary aliphatic amine gives alcohol, primary aromatic amines give phenol, whereas secondary will also uh, give the same product. Like Okay, here secondary will form nitrosodialkyl amine, and the last one again with aryl sulfonyl chloride. This reaction works as distinguishing test. Okay, primary and secondary gives the test, but tertiary doesn't give the test. But primary will be soluble in excess alkali, secondary will be insoluble. Okay. Yes, students, today's class is done. Let's wind up the class. Thank you so much.